This lesson connects solving multi-step equations to solving systems of linear equations by substitution. Let's review what it means to solve a multi-step equation. Now, in this equation, we have the variable x shows up in two places. There's still just one variable, and solving for that one variable requires multiple steps, hence this multi-step equation. So the first step, if you remember, I talked about yesterday, was to, if there are parentheses, distribute. This is whether there are just parentheses on one side or parentheses on both sides. Now, the most common error is to forget that that is a -2 in front of the parentheses. The coefficient of the quantity is a -2. Distribute the -2 and rewrite it as 8x subtract 6 subtract 10x equals -10. Now at this point, the next step is to combine like terms. And we combine an 8x and a -10x. Again, the most common errors here are to not recognize when these operations, addition and subtraction, function as the negative and positive values attached to those terms. Combine those two, we get -2x, -6 does not change, and the equation simplifies to -2x subtract 6 equals -10. Now another common error is as you're simplifying these problems, or this problem, when you're simplifying, a lot of students tend to forget to transfer all the information down to the next piece. It's a transcription error. So transcription error, arithmetic errors are two very common errors. They don't address whether or not you can solve a problem. It's more that those are more those have more to do with precision and perseverance. So be careful about those. So at this point, you're combining like terms, and then from here, all you need to do is add 6 to both sides, simplify, and solve. We're basically isolating this single variable x, isolating the variable, and the answer ends up being 2. Now, what does this have to do with systems of equations? Well, you won't be able to solve a system of equations by substitution if you are not able to solve a multi-step equation. Well, take a look at this. This value, this expression, 3 plus 5x, is in place for whatever's in here. Here's a system of equations. I can substitute 3 plus 5x in for y because it's equivalent to y. These are two conditions that have to be met in order for me to find a solution, if there is a solution, for both equations. If there's a solution for the system of linear equations, it's going to be a single point, because linear equations, when graphed, form lines, and lines, two lines, only cross at one point if they cross at all. If they're the same line, they have infinitely many solutions. If they are parallel, they have no solution. If they have one solution, it means they intersect only at one point. So those are the three possibilities. One solution, infinitely many, or no solutions. Now, I know this one has one solution. To solve a system of equations by substitution, look for a way to substitute part of one equation into the part of another equation. We know that 3 plus 5x is equivalent to y. We can substitute it in for y in the other equation. Now, once we have it substituted in, we are back to seeing this piece. Common errors. You'll see your friend substituting something in for the other variable. That's very common. Again, just if you have that habit of not paying attention to the details, not looking at the precision of the activity, then please watch for that. It's equivalent to y, substitute in for y. There will be scenarios in which you have something equal to x and you can substitute that in for x. In this case, y equals something, that something can be put in for y in the other equation. At this point, you're solving a multi-step equation. That's it. So the difference between solving a system of linear equations and solving a multi-step equation is just one more layer of information, which is, oh, here's my system. I can set it up as a multi-step equation and then solve it. That's it. We know from having done this problem that we substitute 3 plus 5x in for y, we get x equals 2. Now that we know that x equals 2, we can take the 2 and substitute it in for x. X equals 2, there's an x. And rewrite this equation as y equals 3 plus 5 times 2. That's 13. Y must be equal to 13. Now, I know when x equals 2, y equals 13 for this equation. If it works for this equation, those same two values, 2 and 13 for x and y, then I have a solution for the system. Let's input 2 and find out if we get 13. Instead of just substituting 2 in for x, I want to test if 13 actually works with y when 2x works for x. So it's going to be a faster way to check. I know that 2 comma 13 works for this first equation. Does it work such that 8 times 2 is 16? Subtract 2 times 13 is 26. Is that equal to negative 10? Absolutely. So my solution to the second equation is 213, and my solution to the system is 2 comma 13. If I were to graph both these equations in intercept form and standard form, the two lines would intersect at 2 comma 13. So here's a system of equations that you can use to check your understanding. You have two equations, both written in standard form. And I'm going to suggest that you use substitution. At present, there's no equation that's written in terms of just a single variable, x, or a single variable, y. You don't see x equals something or y equals something. But here's a hint. Can you change the second equation or the first equation so that it looks like a y equals or x equals? You can add 2x to both sides and you get y equals 5 plus 2x. 5 plus 2x can be substituted in for y in this equation. You could add 3y to both sides and you would have x equals negative 30 plus 3y. Negative 30 plus 3y could be substituted in for x in this equation. Two ways to solve this problem. Give it a try and see what you come up with. Pause the video and attempt the work. Thank you. if you came up with a solution 3, 11, the coordinate 3, 11, if we were to graph both equations, these two lines would cross at the coordinate 3, 11 on the coordinate plane. If you have any questions, email me, send me a message through Canvas, or show up at the ASL time or my office hours. Thank you.